Welcome to A1 injection of OWASP top 10. So it is an attack where an attacker will inject some malicious command or some malicious query inside the web application and retrieve some juicy and sensitive information. Let's start about it. Injection flows such as SQL, NoSQL, or operating system and LDAP injection occurs when untrusted data is sent to an interpreter as a part of command or a query. The attacker's hostile data can trick the interpreter into executing unintended command or accessing data without proper authorization. How can we check whether our application is vulnerable or not? Let's see. An application is vulnerable to attack when user supplied data is not validated, filtered, or sanitized by the application, which means raw data which has been directly inserted by the user is directly executed. Dynamic queries or non-parameterized call without context. Aware escaping are used directly in the interpreter. Hostile data is used within object relational mapping, that is ORM search parameters to extract additional sensitive records. Hostile data is directly used to concatenate it, such as the SQL or command contains both structure and hostile data in dynamic queries, commands, or stored procedure. Some of the more common injections are SQL injection, NoSQL injection, OS command injection, object relational mapping injection, LDAP injection, expression learning injection, object graph navigation library injection. The concept is identical among all interpreters. Source code review is the best method for detecting if applications are vulnerable to injection, closely followed by thorough automated testing of all parameters, header URLs, cookies, JSON, SOAP, and XML data input. Organizations can include static source, that is SAST, and dynamic application test, that is DAST, tool into CI/CD pipeline to identify newly introduced injection flows prior to production development. Let's look into one of the example. So we have got a testing website on which we can try. So the very foremost requirement is to find a get parameter. Either you can find get parameter by entering something inside the search box or by clicking somewhere inside the on the hyperlink. Since we are having a get parameter, let's try to break the query of the same. And yes, we are having an error flow or a SQL flow. Since it is partially parameterized query, so we won't be needing a single inverted comma for breaking it further. Let's count the total number of columns here. Order by 1, minus minus plus. No error we are getting. Order by 2, minus minus plus. Order by 3, minus minus plus. Let's use binary jumping. Order by 4, minus minus plus. 4 plus 4 is 8. It's still there. 8 plus 8 is 16. Okay, so that the total number of columns present is between 8 and 16. 8 plus 16 is 24, divided by 2 is 12. Okay, which means between 8 and 12, 20 plus 10. So let's check it out. Okay, which means it's either 11 or 12. Okay, there are total 11 number of columns. On the 12th number we are getting the error. Since we know there are just 11 number of columns, so we can use union clause. union select 1 comma 2 comma 3 4 5 6 7 8 9 10 11 minus minus plus. So this will give me an unwanted data. There are these three numbers which represent the vulnerable columns 2, 7 and 9. Let's try some information. That is, inside, instead of 2 I am going to write user, instead of 7 I am going to write the version information, and instead of 9 I am going to write database. And see, I am getting the user accurate @localhost. I am getting the database name as well as the version. So let's try to extract some information about table underscore name from information underscore schema dot tables. So here we are having all the table names present here. Since there are so many tables, we want to narrow it down. We want to narrow it down by selecting just one table which can contain some juicy information, and that seems like users. So let's calculate, or let's count the total number of columns again here. Or let's extract the column names from information underscore schema dot columns, where table underscore name equals to users. And here we are having all those data here which are present inside this information. So we are having cart, we are having CC, we are having email, we are having name, we are having pass, we are having phone. So we need only uname and phone. So I'll be just extracting uname and just the pass. From this time I won't be using any schemas column. I'll be just going for the directly the table name. And here we are with these two columns. So that's how a SQL injection can be utilized. How we can remediate and mitigate. Preventing injection requires keeping data separate from command and queries. The preferred option is to use a safe API which avoid the use of the interpreter entirely or provides a parameterized interface, or migrate to the ORM tools. When even parameterized stored procedures can still introduce SQL injection if PL SQL or T-SQL concatenates queries and data, or execute hostile data with execute immediately or exec. Use positive or whitelist server-side input validation. This is not a complete defense, as many application requires special characters such as text areas or APIs or mobile application. For any residual dynamic query, escape sequence characters using the specific escape syntax for that interpreter. Note: SQL structures such as table name, column name, and so on cannot be escaped, and thus user supplied structure names are dangerous. This is a common issue in report writing software. Use limit and other SQL controls within queries to prevent mass disclosure of records in case of SQL injection. In next video, we'll be studying about A2 broken authentication of OWASP top 10. Thank you.
Subscribe now and press the bell icon. Never miss an update.